Okay, guys, I'm back. Sorry about that. I'm gonna say it's a funny story, but it really hasn't been a funny story. Okay, I'm sure that by now a lot of you already heard the story. I don't even know if I'm gonna rehash it here. It would take me till it's 1:30. It would take me till 2 o'clock to go through the whole thing. I tried to order a TV online. Don't ever do it. Just don't ever do it. I ordered it on November 2nd. Right now it's 12/23. They delivered 3 TVs damaged to me. 3. I'm waiting for the 4th. I was supposed to get it today. They told me today it's going to be 12/28. It's going to be like 2 months by the time this is done, just to get a TV set. I'm a TV guy, all right? So, they didn't want this one back, so I'm going to see if I get a guy that can fix it. If this guy can fix it for like $200, I'm going to keep it. And I'll have 2. But I don't think he's going to be able to fix it. He's called me back. I got to bring it there today. All right. So, dependent, independent. All right. So, if we had something like this, like up on the board, it says A equals pi r squared. You're going to say A is a function of r. The area of a circle is a function of its radius. The bigger the radius, the bigger the area. The smaller the radius, the smaller the area. That's how it works. That's what it means when they say is a function of. Okay? The area depends on the radius. So this is dependent, this is independent. Okay? You pick a bunch of different radiuses, you'll find a bunch of different areas. Right? So that's what dependent and independent variables mean. Do I want you to read that now? All right, so I'll just write these on the board. You guys probably can't even read that when you see it up there. So let me give you what's called implicit form and explicit form, that type of stuff. So, ready? This is called implicit form. Implicit. X squared plus 2y equals 1. Okay? Explicit form. So implicit form, you get your x's and y's on the same side. Okay? Get your numbers on the other side. Explicit form would be like this when you solve for y. 1/2 times x minus 1 squared plus 5, something like that. Explicit. Solved for y. Okay? And then we have what's called function notation. And it's just a fancy way, to write an equation like this. You write f of x. It's a little bit more sophisticated. You'll see it in higher math. I'm sure you've seen it in pre-calc. You've seen it in algebra 2. For those of you guys that had me in algebra 2, you've seen it. Okay? So it's just a more sophisticated way of doing it. The higher up in math you go, the less you see it written like this, the more you see it with f of x. So this would be the dependent, and again, your x is still your independent. All right? Again, a little thing with notation, okay, with notation, and then we're going to start practicing some problems. You guys will appreciate the practicing problems. You could have like this, like f of x equals x squared minus 4x plus 7. You might have f of t equals t squared minus 4t plus 7. F of s equals s squared minus 4s plus 7. It's just notation. It's just notation, okay? We're used to so much with x and y. Again, the higher you go up, the more you'll see other letters used. All right? All right, here we go. Let's do some work. Let's do some problems. This stuff's boring. You go over notes like that. It's boring. Boring for me. But I want to give you good notes. my hope is that with these notes, you take them with you to college, and when you have a calculus class, that it's easy for you. That's my goal. That's my goal. My goal is to get you ready. Get you ready for, I want you to have fun, but fun is not my #1 priority, okay? You want to have fun, go take a film, okay? I want to get you ready. I hope we have fun at the same time, but I want to get you ready for next year. So, example number 1, for the function f of x equals x squared plus 7, find f of 3a, f of b minus 1, and then the big mama, f of x plus delta x minus f of x over delta x. And you're going, what? What? That's when it gets fun. Okay, that is when it gets fun. So let's do it. Let's do it. I'll do it right here. So, f of 3a. Well, my f of x says x squared plus 7, so it tells me here that's what I want to plug in. This tells me that whatever's in parentheses here, I square it and I add 7. Well, now I've got f of 3a. So I have to take 3a, square that, and then add 7. So I'm going to have 3a squared plus 7. 3a squared, 3 times 3 is 9, a squared. 9a squared plus 7, done. Okay, 9a squared plus 7. Now next one. It says, what do you think of that, Vince? I think you'd be impressed. So the next one says f of b minus 1. F of b minus 1. So that means that the b minus 1 is in parentheses. I have to square that and add 7. So I'm going to have b minus 1 squared plus 7. Okay. B minus 1 squared. Don't write b squared plus 1. Stop it. Stop it. You got to square it. You got a middle term. B times b is b squared. Minus b is minus 2b. -1, -1, plus 1, plus 7. So that's going to be b squared minus 2b plus 8. All right? What do you think of that? What do you think of that? Good stuff. I like it. Good stuff. All right. So, I don't want to do that one. So, let's look at the next one. Now, the next one's the one that's going to get you. If there was one that was going to get you, it's going to be this next one. Okay? But if we follow the same rules, the rules are the same. Okay? The rules are exactly the same. It says f of x plus delta x minus f of x all over delta x. Now, the advantage that you guys have if you're watching this as a video is that you can go back. You can go back and you can pause this or you can watch it again and maybe it'll make sense the second time that you see it. Okay? Let's look. All we're going to do is follow the rules. This is what they're telling me to do, and I'm going to plug it in. And the rest is algebra. Don't get intimidated because you see something that you haven't seen before. Most of the time when you do that, you're going to rely on the properties and the things that you've learned to this point. Okay? So let's look. It says f, I'll do it down here because I'm going to need the space. So I go to my function, and I'm going to plug in x plus delta x. Well, my function says that whatever's in parentheses, I square it. Okay? So this is going to be x plus delta x squared. plus 7. Okay? All I did, we did 3a, we did b minus 1. Now I have x plus delta x. So that's what goes in here in parentheses, so it gets squared, and then I add 7. Now it says minus f of x. So I gotta do minus, and I would really strongly encourage you to put parentheses there. Minus x squared plus 7. And that's all divided by delta x. So take a look at it. See if that you can absorb that, okay? Nothing that crazy there. It really isn't, okay? It's different, sure. Sure it is, okay? But it's nothing that you can't do. Nothing that I have all the confidence in the world you can do that, okay? So let's do some math now. Okay, do some math. We're gonna square this, okay? So I think I'm gonna do it up here. I'll do it a different color and I'll do it up here. X plus delta x times x plus delta x, okay? We do a little foil for you today. A little foil. X times x is x squared. X times delta x is x delta x. X times delta x is x delta x. And delta x times delta x is going to be delta x squared. So when I add that together, I can go back to my problem now. I'm going to have x squared plus 2x delta x plus delta x squared minus x squared minus 7 all over delta x. Okay? So we have some simplifying to do here. We have some simplifying to do. Let's look. I forgot to write something down. Maybe you guys caught it. So I did the x plus delta x squared. I forgot to put the plus 7. So I'm going to add that right here. All right? Let me modify this a little bit. My mistake. I hope you guys caught that. You guys caught it. Good for you. I make mistakes. I make them all the time. Plus 7. Okay. So now, we cancel what we can. Ready? X squared and negative x squared cancel. 7 and negative 7 cancel. So I'm left with 2x delta x plus delta x squared, all divided by delta x. So I can factor out a delta x now. So if I factor out a delta x, I'm left with 2x plus delta x, all over delta x. And then my delta x is canceled. So my answer is 2x plus delta x. How about that? We're going there. That's where we're going. That's where we're going. Okay, chapter 2. You're going to get sick of hearing about that delta x. Okay? But that's what we do. Okay, that's what we do. All right. Good stuff. Good stuff. Persevere. Persevere. Not everything's going to be easy here. It's not going to be hard. But not everything's going to be easy. I hope that you get challenged. I hope you have some days where you're like, man, I don't know if I can get this. Because then it prepares you for the challenge of college. Prepares you for that. Okay? So the next thing we're going to talk about is domain and range. Okay? Domain and range. You've done it before, Algebra 1, Algebra 2, probably pre-calculus. Domain, input, x. Range, output, y. Okay? And now we're going to deal with some functions. Okay? So let's look. Letter A. F of x equals root x minus 1. So with a lot of domain and range problems, if you have something that's linear, if you have something that's quadratic, there are times when you just have all real numbers, okay? That's just the way it is. The problems come in when we have square roots, when we have fractions, and when we have trig functions. So the three examples that I'm going to go over with you is a square root, a trig function, and a fraction, okay? So, Here we go. Domain. Numbers I can plug in for x. So we're going to start with an inequality, and then we're going to work our way up to brackets and parentheses, because that's the way big girls and boys do it. Brackets and parentheses. There's all kinds of noise out here. Hold on. Some people are already on vacation. I don't have that luxury. I got basketball season coming up and other things that are going to keep me away. I got to get these videos cranking. So, let's think about square roots. What happens with square roots? With square roots, we cannot have negatives in there. Okay? So when you look at this one, the smallest number that x can be is 1. Because if x is anything smaller than 1, I'm going to get a negative number there. So I'm going to say x is greater than or equal to 1. Okay? And we'll come back after and we'll write it the way I want it. Okay? Now my range. Think of your XY chart. Okay? Think of your XY chart. If you can plug in a 1, you can plug in a 2, you can plug in a 3 and a 4 and so on. It's good to sometimes plug some values in to get a feel for what the range is, to get a feel for what your answers are. So if you plug in a 1, you get 0. You plug in a 2, you get 1. You plug in a 3, you get root 2. You plug in a 4, you get root 3. But you can see the pattern. You can see the smallest value is a 0. So my range is going to be y is greater than or equal to 0. Now, how do you want to write that? We want to write it, we want to be sophisticated when we write this. Okay? We want to be big boys and big girls. So I write this with a bracket and a 1. That means it includes it. That means it includes it. And we go to infinity with a parenthesis, because you can never bracket infinity. Okay? Infinity always has a parenthesis. So for this one then, excuse me, we are going to say 0 to infinity. All right? All right. Now, take a look at that. Make sure you copy it down, because I'm going to have to erase it, because I do want to use this. I've got to find an appendix that I use that I'm sure, if I was smart, I gave you guys a copy of the appendix. I certainly hope I did. Because the next one, yeah, found it. The next one is going to involve the appendix on page A23 of your textbook. Okay? Graphs of trigonometric functions. So let me erase this. And our next one is going to be number 2. F of x equals the tangent of x. Tangent of x. Let's see if that's all I want. Yeah, tangent of x. Okay? And we're going to talk about the domain, and we're going to talk about the range. Now I told you, trig functions we have to worry about with domain, square roots and fractions. Now, tangent is a trig function, but it's also a fraction. That is sine x over cosine x. So we have to be concerned where cosine is equal to 0. So, at some point we're going to do a little trig review or a trig learning session. Because with COVID, I'm not sure exactly what Mr. Fazio was able to get with you. I'm sure it was a lot harder to explain trig functions remotely. We have to worry about where cosine is 0. So I want to go to our unit circle. Okay, our unit circle, because that's what I always do. I break down trig functions to the unit circle so we have an understanding of it. And once you have the understanding, then you can go and answer the question. This is 0. This is pi over 2, which is 90. This is pi. This is 3 pi over 2. Where is cosine 0? Where is your x 0? Your x is 0 here and here. Okay? So if I'm looking for my domain, I can't have